I'm Anil Kumar. Welcome to my series on sharing with you previous test papers. Here is a test paper of an IB student who is doing functions. It's a pre-calculus course. We have 9 questions in this test paper. Time allocated is 1 hour. 75 minutes can be given in a proper test. I would like you to pause the video, copy these questions, and then solve them. Once you have solved, look into my solutions. So we'll take our time, about 2-3 minutes, to go through the first 9 questions and then solve them one by one. This video may take about 45 minutes. Question number 1. For the following relations, determine if they are functions. You need to find the domain and range. So these are the two functions. Here is also a point, right? Keep that in mind. Question number 2. For f of x equals to 2x minus 7, determine f of 5, f 3x minus 2, and f inverse of 2. Question number 3. F of x equals to 2 over 5x minus 5. Calculate f of minus 25 minus f of 10. Question 4. The graph of y equals to f of x is shown. Sketch graph of inverse of this particular given function. Is f inverse a function? So this is f inverse, right? So treat this as f inverse. Determine the value of f inverse of 2. Question number 5. Given the function g of x equals to set of coordinates minus 2, 3, 4, 6, 6, 8, 8, 9. List the ordered pairs that belong to the transformed function y equals to 3g minus 2x. Question 6. The function g is g of x equals to 1 by 3 f of minus 3x minus 9 minus 8. List the transformations to transform f to g. Suppose the domain of f is x belongs to real numbers, where x is greater than or equal to 3 and less than or equal to 9, and the range is y belongs to real numbers, y is greater than or equal to 6. Determine the domain and range of g. Question number 7. The graph of y equals to f of x is shown. You need to sketch the graph of y equals to minus f 2x minus 2 minus 1. Question number 8 has 2 parts. Part A. Write domain and range of y equals to minus x squared plus 2x plus 1. And B is determine f inverse and then evaluate f inverse of minus 2. Question number 9. Sketch graph of y equals to 1 minus 2x plus 4. Absolute function. Perfect. Question number 10. This is the last question. Find the x-intercepts of the function f if the x-intercepts of its transformed function g, where g equals to 5f within brackets 2x minus 6 are at 2 and 6. Perfect. So these are the 10 questions for you. You can always pause the video, answer these questions, and then look into my suggestions. Now let's solve them one by one. Correct? Here is the very first one. We are given 2 relations here. Let's call them A and B, right? So this is our relation A, this is relation B. First thing, we need to say whether these are functions or not, right? Clearly. The first one, here we have a closed cell, right? And this one is open, correct? Open circle, closed circle. That means it is a function. So this one is a function. However, here, if I draw a vertical line, it crosses through 2 points, correct? So if I draw a vertical line, it crosses at 2 points. So this one is not a function. Domain. Now, how do you write domain of such a function where a point separately is also given to you? Well, let's try to figure it out. So what you can do here is you said x belongs to real numbers, so that, and put it in curly brackets. That is the set of. Now on the left side, you see at -3, there is a jump discontinuity, right? So it is, however, the domain is like continuous till this point, which is 3. So you can say x is, and this point is filled in circle, so it is less than equal to 3. Now after that, we have x equals to 4, and then we have x equals to, at 4 there is a point, x equals to 4. So that is how you could include the other points. I hope that makes sense, right? Now let's write down the range of this function. Now as far as the range is concerned, the range is from -4 to 2, right? This point is included. And then after 3, right? So we could write range as y belongs to real numbers. And it is from -4 to 2. So -4 to 2. And after that is greater than 3. Do you see that? It's greater than 3. 3 is not included. And then y is greater than 3. So that is how, for a split function as shown here, you need to write the domain and range, right? This is not known to some of the students, so I hope that helps. Now, in part B, it is not a function, but you see from 2, it is only on the left side. So the domain here is that x belongs to real numbers, right? Where x is less than equal to 2. As far as the range is concerned, it is all real numbers, right? So the range is y belongs to real numbers. There is no restriction. Perfect. So I hope you understand this part. Let's move on and take question number 2. For function f of x equals to 2x minus 7, determine f of 5. So that is simple. Just substitute 5 and you get 2 times 5 minus 7, that is 10 minus 7, that is 3. So you get your answer that f of 5 is equal to 3. Now we need to find what is f of 3x minus 2. So 3x minus 2, you have to replace x with 3x minus 2. Correct? So let's do this. So f of 3x minus 2 is equal to 2 times, replace this x with 3x minus 2, right? And then solve. So open the bracket, you get 6x minus 4 minus 7. That gives you 6x minus 11. So that becomes the solution for the second part, right? Now we need to find inverse of this particular function and the value at 2. So in step 1, we'll find what is inverse of the function, right? Now to find inverse, what should you do? We have to swap x and y, right? So let's see how to find inverse first. So to find inverse, we'll swap x and y. We are given y equals to 2x minus 7. We'll swap. We'll say x equals to 2y minus 7. Then we'll isolate y. So we get x plus 7 equals to 2y, or x plus 7 divided by 2 is equal to y. Correct? So from here, we can write that f inverse of this particular function is equal to x plus 7 over 2. We need to find f inverse of 2. So let's substitute 2 for x. So we get 2 plus 7 over 2. And that gives you a value 9 over 2 or 4.5. Correct? So that is how you get your value. So we find that f inverse of 2 is equal to 4.5. Question number 3. If f of x equals to 2 over 5x minus 5, calculate these values. So we just substitute these values, right? So let's first find what is f of minus 25 equals to. That is 2 over 5 times minus 25 minus 5. And that is, we can cancel this 5 times, correct? So you get minus 10 minus 5, or it is equals to minus 15. Let's find f of 10 now. F of 10 will be equals to 2 over 5 times 10 minus 5. That is, so it can be divided by 2. You get 4 minus 5, or minus 1. And therefore, we can now write f of minus 25 minus f of 10 equals to minus 15 minus of minus 1, which is minus 15 plus 1, or minus 40. Clear? So I hope you find it simple and useful, right? It's good to calculate individually and then do the algorithm. Question number 4. The graph of f of x is shown to you. Sketch the graph of f inverse x. Is f inverse x a function? Well, this part, when we say is f inverse x is a function, we test it using a horizontal line, correct? So if I draw a horizontal line here, you see it crosses at 2 points. Perfect. So clearly, inverse is not a function, right? So make a note that we know that this is not a function. So inverse is not a function, since f fails horizontal line test. Perfect. Determine the value of f inverse of 2. So that is the second part. So I'd like you to pause the video, sketch it, and then look into my suggestions. Now to sketch inverse of a function, I will suggest that mark points, right? So these are critical points, A, B, C, D, and E. So let's write down the coordinates of these points, right? So for A, the coordinates are minus 4, minus 3. For B, the coordinates are minus 2, 0. For C, the coordinates are 0, 4. For D, the coordinates are 2, 4. For E, the coordinates are 4, 0, right? Now, when you want to find the inverse, then these coordinates will swap, correct? So for inverse, we need to swap them. So let us write down the coordinates once we have swapped them. So we have A dash, the image, will be minus 3, minus 4. So just interchange. Do you see that part? 0, minus 2. C dash will be 4, 0. D dash is going to be 4, 2. And E dash is going to be 0, 4. Correct? So that is the best way to sketch the inverse. You could also reflect it on the y equals to x axis, but this is better, right? So let's now write down these points. So for A, we get A dash, which is minus 3, minus 4. So it comes to minus 3, minus 4. So that becomes A dash for you, correct? B dash is 0, minus 2. So it remains there itself, right? So minus 2, 0, 0 minus 2. So at 0, at minus 2, that becomes B dash, right? Gets reflected. C dash is 4 and 0. So 4 and 0. So that point becomes C dash. So this point is reflected here. Now D dash is 4 and 2. 4 and 2. So that becomes D dash. And E dash is 0 and 4. So that this reflects back and becomes D dash. E dash. Is that clear? So that is how you get your transform points. And now you can join them using straight lines. Correct? So I'll make a rough sketch here. So we'll just join them. So we have, this is first set. Then we have this point. And then from here, we have 4, 0 and 4 and 2. So 4 and 2 it goes up 2 units, and then from here we go to 0, 4, which is this point. Correct? So that becomes the inverse of this, right? So we see that inverse is not a function, that is the inverse. And clearly it fails a vertical line test, right? So if I now sketch a vertical line, it actually intersects at many points. Perfect. So it is not a function. So this is not a function. Now, we have already done the sketching part. Determine the value of f inverse of 2. So that is to say, you could do, now on inverse function, if x is 2, then what is the value of the function? So these are the 2 points which you get. So this is x equals to 2, right? So these are the 2 points which you get, and their value is 3 here and -1 from the graph. Correct? So determine the value of f inverse of 2. So we get 2 values for this. So f inverse of 2 is equal to -1 and 3. So these are the 2 values. Well, you could have also found these values from the function itself. Now in function, we'll look at y value of 2, right? So y value of 2 will give you this -1 and here as 3, right? So if you draw this line, this is the point, right? So this is 3. So from the function also, you could have read this value in the reverse order. Perfect. Now some of you could have actually sketched the inverse by reflecting on the line y equals to x, right? So let me just draw y equals to x line here, right? So it is not that accurate, but still. So you could reflect on y equals to x to get your points. So I hope that makes sense. Perfect. Okay, let's move on to question number 5 now. Given the function g of x, list the ordered pairs that belongs to the transformed function y equals to 3g minus 2x. Now we are looking for points on y equals to 3g minus 2x. Now what is the transformation? So if the coordinate is x and y, then the transformed coordinate is the x values get reflected and divided by 2. So we get minus x by 2 and the y values get multiplied by 3. Correct? So that is the transformation which is being applied. Correct? So let's rewrite our points here and then we'll find the transform points. We have -2, 3 and then we have 4, 6 and then we have 6, 8 and 8, 9. Correct? So the x value has to be negative, so they will become negative and divide. So it becomes 1. The y value should be multiplied by 3, so we get 1 and 9. Do you see that? Now the second one will become negative and then divide by 2, so we get 2. The y value becomes 18. Here again negative 3, 8 times 3, 24. And 8 gets divided by 2 with -2, right? So -4, and 9 times 3 gives you 27. So those are your transform points. So I hope you have understood how, using this transformation, we have got the transform points. Perfect? Question number 6. A function g is g of x equals to 1 over 3 f of minus 3x minus 9 minus 8. List the transformation to transform f to g, and then we have domain and range related question. Now, in this question, sometimes you can make a mistake by not looking into the inside part carefully. We should always factor out this number, right? So we have 1 over 3 f of, let me factor this out. So we get minus 3. When you factor minus 3, you get x plus minus 9 divided by minus 3 is 3. minus 8. So once you factor, you get the correct horizontal translation. Otherwise, you could have done a mistake, correct? Now, list transformations. In listing transformation, we do multiplications and reflections, stretches and compressions first, and then we write translations, correct? Now, you could start from left to right. In that case, you do not really make a mistake. Let us write down all the transformations. So 1 over 3 means vertical compression by a factor of 1 over 3, correct? So that is the first transformation, vertically compressed. Now as we move inside, everything is horizontal, right? So minus here means reflection on which axis? Y-axis. It's horizontal, right? And then 3 means horizontally compressed by a factor of what? 1 over 3, right? So all the points will come closer horizontally. Now this is horizontal translation. So you can say translate 3 units left. You can combine translations together. We'll write them separate though. So here translate vertically 8 units down. So these are all the transformations. Perfect. So first part has been done. Now let's look into part B. Suppose the domain of f is x belongs to real number and x is between 3 and 9. And the range is y belongs to real number, y is greater than or equal to 6. Determine domain range of G, right? So again, we'll look into the transformations, right? So x and y has been transformed. What happens to the x values? You have to divide them by 3 and reflect, right? So we have minus x over 3 and then minus 3 since it moves 3 units left, minus 3. So that becomes transformation of point. X points changes like this. Y points, we get y over 3 and then you take away 8, right? So that is the transformation, correct? Now in our case, we have domain x, which is between 3 and 9, right? So between 3 and 9. So on this, we'll apply this part, correct? So what we have to do here is each point, which is 3, will make it negative and then divide by 3, correct? So if I divide by 3, it changes to 1 and negative means it is minus 1. Is it okay? So when I divide by 3, it becomes minus 1, and when I do minus 1 minus 3, it becomes minus 4, more negative, moving left. Is that clear to you, right? On the other hand, when we have 9 here, when I divide 9 by negative, it means negative 3. It becomes negative 3. And negative 3 is negative 6. So x value is in between negative 4 and negative 6. Correct? Remember one more thing. Whenever you have minus, inequality sign will also change. So we have this sign going the other way. So it makes sense. X is greater than minus 6 and less than minus 4. Correct? Right? So that is kind of important to understand. Now let's look into the range part. We are saying y is greater than or equal to 6. Now if I do this transformation, I'm dividing by 3, making it 2. So we get y is greater than or equal to 6 divided by 3 is 2. 2 minus 8 is minus 6. Correct? So that becomes the range for the transformed function. So the domain and range for the transform function is going to be this. Is that clear to you, right? So we applied the transformation to get the right answer. I hope it makes sense. Question number 7. The graph of y equals to f of x is shown. Sketch y equals to minus f 2x minus 2 minus 1. Well, you can actually sketch it on a graph paper. This is not very clear. So I'll again make some estimates, right? But before beginning to sketch, let's rewrite our function. So whenever you have a transform function like this, it's always important to factor the inside part, right? So we get x minus 1 here, right? Minus 1. So now again, we will actually find these critical points and transform them using the transformation. The transformation should be xy will be transformed to, the x values will be divided by 2, so half of x, and move 1 unit to the right, so plus 1. The y values will be reflected on x-axis, so minus y, and this is minus 1, correct? So let's mark these points here. We have, let's call this as A, this is our B, C, D, and E. So I'll write down these points. So A is minus 4. In this case, it seems to be minus 4 minus 3. B is minus 2, 0. C is 0, 4. D is 2, 4. And E is 4, 0. Now when we apply the transformation, we have to divide the value of x by 2 and add 1. So A dash will be, dividing by 2 is minus 2, plus 1 is minus 1. Negative of 3 is 3, 3 minus 1 is 2. As far as B dash is concerned, half of this is minus 1, minus 1 plus 1 is 0, and this is 0 minus 1. C dash, 0 means 1, and 4 minus 1 is minus 5. D dash will be 2 divided by 2 is 1, 1 plus 1 is 2, 4 negative, negative 5. As far as E dash is concerned, 4 divided by 2 is 2, 2 plus 1 is 3. And this is 0 minus 1, so we get minus 1. So these are the transformed points, right? So let's plot these points. A dash, minus 1 and 2. So minus 1 and 2 means that 0 minus 1, 0 minus 1. 1 minus 5. So at 1 we have minus 5. Okay. At 2 we have minus 5. At 3 we have minus 1. So at 3 it is minus 1. So that becomes the transformed graph of the given function, right? So it is going to be kind of like this. Correct? So that is how you could sketch the transformed function, right? So let's call this as g of x. So I hope these steps are absolutely clear. Perfect. Now let's move on and take question number 8. Question number 8. Write domain and range of y equals to minus x squared plus 2x plus 1, and b is determine inverse of this function and then evaluate f inverse of minus 2. So to find the domain, we know domain is all real numbers. That's not a problem, right? So we know domain is x belongs to real numbers. Now to find range, we need to write this in vertex form. It is a parabola which opens downwards, right? So this is a parabola which will open downwards, so we need to find the vertex. That's the whole idea. Once we know the vertex, we can always write domain and range. Now there is an easy way of finding vertex, that is minus b by 2a we could use, but we'll go with completing the squares. So we have y equals to minus x squared plus 2x plus 1. We can take minus 1 common. So we get x squared minus 2x plus 1. Now we'll do half of 2. So we get 1. So we'll add and subtract 1 square to it, right? These are the steps involved. So that gives you x minus 1 whole square. Minus comes from here, 1 from there. Minus 1 square is minus 1 plus 1. Open the bracket. So that gives you minus x minus 1 whole square plus 1 plus 1. And that is minus x minus 1 whole square plus 2. Correct? So from here, we know the vertex is at 1, 2. And therefore, we can now write range is y belongs to real numbers so that y is less than equal to 2. Correct? So that is how you'll find the range. Now let's find inverse of this function and then evaluate f inverse of minus 2. To find inverse, we'll swap x and y. So we can write this as x equals to minus y minus 1 whole square plus 2. Bringing it this side, x minus 2 equals to minus y minus 1 whole square. Dividing by minus, we could write this as 2 minus x, for example, equals to y minus 1 whole square. Then we'll do square root, right? So when you do square root, it's plus minus 2 minus x equals to y minus 1, or y equals to, bringing 1 here, 1 plus minus square root of 2 minus x. Correct? So that gives you the inverse. So we can write f inverse is equal to 1 plus minus square root of 2 minus x. Correct? Now we need to find f inverse at minus 2. So if I substitute minus 2 here, then I get the value at minus 2, which is 1 plus minus square root of 2 minus minus 2, which is 1 plus minus square root of 4, which is equals to 1 plus minus 2. So we get two answers here. One is 1 plus 2, which is 3, and then we have 1 minus 2, which is minus 1. Correct? So these are the two answers. Correct? So that is how you could solve it. So we have answer as minus 1 and 3. So I hope the steps are absolutely clear, right? At times, you may write inverse as, you may write this f inverse. Let me just write here. Also, you could write f inverse as square root of minus x plus 2. Of course, plus minus and plus 1. But the way I wrote is also okay. Correct? Question number 9. Sketch the graph of y equals to 1 minus absolute value of 2x plus 4. Now that's an absolute function. So absolute function looks like what? Well, the absolute function is a function which is like this, right? It's y equals to x, and then you reflect the minus part, right? So we'll sketch from this function the required transform function. We'll use transformations, right? So we have a function here, y equals to 1 minus absolute value, like 2 common, and we get here x plus 2. Correct? So if I write xy coordinates, they get transformed to the x values get divided by 2 and then take away 2. Correct? The y values, now since this is negative outside, right? So you think like this. It is like this. Negative of 2 times x plus 2 plus 1. See, so this negative is for y, right? So don't get confused. So it's y plus 1. Do you see that part? So that is how you are going to get the function, right? So on your scale, let's draw some take some critical points. So for sketching this function, 3 points are enough. One is 0, 0. Then we could have minus 1, 1 and 1, 1, right? So minus 1, 1 and 1, 1. If you want, you could have 5 points, right? So 2, 2 and minus 2, 2, right? Okay. So let's write minus 2, 2. So we'll take these 5 points. So let me do it like this now. Since it is divided by 2, it's good to take those even numbers. Correct? So what do we get here? When you divide x by 2, this becomes minus 1. Minus 1 minus 2 is minus 3. Correct? The y value, negative 2 plus 1 is negative 1. When we do 0, 0, I'm skipping this, right? When we do 0, 0, we get minus 2 here and 1 there. And for 2, 2, 2 divided by 2 is 1. 1 minus 2 is negative 1. Minus 2 plus 1 is minus 1. So those are the points. Is that okay? So on your graph paper, what you could do here is something like this. So this is, so you will select the vertex first, which is minus 2, 1, right? So let's say this is minus 2 and this is 1. So that is your vertex. The other 2 points which are symmetric about this is at minus 1, so here, and the other one is at minus 3, minus 1, correct? Minus 3, minus 1. So your function will look like this. Do you see that? So that becomes your transform function. So sketch it on a better graph paper so that there is no problem. Correct? These are my critical points and these are minus 3, minus 1 and minus 1, minus 1. Correct? So that is how you could do it. So I hope that is clear, right? Now we are almost at the end. Last question. I hope you enjoyed the journey and learned while going through these solutions. Question number 10. Find the x-intercepts of the function f if the x-intercepts of its transform function g equals to 5f 2x minus 6 are at 2 and 6. Okay. Now this is a very important question. Here we may have to do some reverse calculations. So what we are given here is a function which has been transformed, and the transform function is 5 of f. So we'll take 2 common, x minus 3. Correct? So here we have x-intercepts at 2, 0 and at 6, 0. We need to find this on original function. Which is f of x. Correct? That is what it is. Now, what kind of transformation has taken place when you move from f of x to this place? So if the coordinate point here was xy, then in this case the point was x value was divided by half and then moved 3 units to the right, correct? The y value was multiplied by 5. So that was the transformation. Now we have to apply reverse transformation to these points. See how it works. Let's take 2, 0 first, right? So we are saying that half of x plus 3 is equal to 2. So find x from here. So we say half of x is equals to 2 minus 3, which is minus 1. So x is equals to minus 2. Do you get it? So we got our first x-intercept, which is at minus 2, 0 in the original function. For the other function, it is 6. So we'll again apply this. We say half of x plus 3 equals to 6. So half of x equals to 6 minus 3, which is 3. And x is equal to 6. Correct? So minus 3 gives you 3 and then x gives you back 6. So the second point is still 6, 0. Do you see that? So whatever this transformation has done, you'll figure this out that these are your new x-intercepts, but actually these are on the original functions, right? So these were transferred to this. So here we have done reverse calculation to find our intercepts on the original function. Do you see that part? So that is extremely important to understand. So on the original function, the x-intercepts should have been at -2, 0 and 6, 0. So that brings us to the end. I hope you find these examples helpful. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'll be great. Thanks for watching and all the best.